What I'm now going to do is, using the law of one price, I'm going to provide a formal argument as to why the lower bound for a European call option has to be S naught minus K times e to the power minus RT. Now for this, let's consider two portfolios, portfolio A and portfolio B. Now I'll just read out what these portfolios consist of, but you'll notice just try and draw a parallel between the portfolios I've created here with the example that we just did, because there is a very strong parallel and the theory is actually emerging from that example. Okay, so portfolio A here is where you have one European call option plus a zero coupon bond that gives an amount K to you at time capital T. Okay, so one European call option is what you have in this portfolio along with a zero coupon bond. Portfolio B is one which consists of one share of the stock. Now what we'll do is, as per the law of one price, we will compare the current value of these two portfolios and the future values as well. Okay, so let's look at these two portfolios. As far as the current value of portfolio A is concerned, because portfolio A is one European call option, so that price is C, and a zero coupon bond which will give K at time period T, that present value would be K times e to the power minus RT. Okay. Then for portfolio B, because it's just one share of the stock, the current value of portfolio B is going to be S naught. The question now is, what is the future value? Again, there are two scenarios. The stock price at capital T could be greater than or equal to the strike price, in which case you will exercise the option. So your payoff from exercising the option in portfolio A would be ST minus K. This is your profit, plus, because you're getting K from the zero coupon bond, this will be your net profit. And for portfolio B, it will be ST, the value of the share at T. The second scenario is where ST is less than the strike price, in which case you will not exercise the option. So the value of portfolio A will just be capital K, what you get from the zero coupon bond, and the value of portfolio B in this scenario would be again just ST. Now what you notice in the first scenario, whether you look at the value of portfolio A or B, because here the K's get cancelled, the value is the same for both portfolios. But in the second scenario, because ST by assumption is less than K, so the value of portfolio A has to be greater than the value of portfolio B. So in general, for the future, we have V sub A, the value of portfolio A is always going to be greater than or equal to the value of portfolio B. So here we have taken into account both the scenarios, and in general this has to be true. So what the law of one price says is that in order to prevent riskless arbitrage, we also have to have the same kind of matching for the current values. So let's now apply this same logic to the current values. So the current value of portfolio A is C plus K times e to the power minus RT, and that has to be greater than or equal to S naught, because the future values are such that for A the value is greater than or equal to the value of B. Therefore, even for the current values, the value of the current value of A has to be greater than or equal to the current value of portfolio B. And now you simply have to solve for C. So you get the result that C has to be greater than or equal to S naught minus K times e to the power minus RT, and that is your lower bound result.